In this segment, we're going to look into the functions of a greater than b and a less than b. Next, we're going to learn how to check whether a is greater than b. So if a is 8 and b is 7, then the output should show us 1, showing that a is greater than b. So the value of a is 8 and the value of b is 7. And this is their corresponding binary representation, which I've written over here. So this is my LSB and this is my MSB. Now let's think about different cases where A is greater than B. Now to check whether A is greater than B, we should always start from the MSB, because see, in this particular instance, since A4 is 1 and B4 is 0, I don't have to check any of the bits. I can just directly conclude that A is greater than B, because the MSB of A is 1 and the MSB of B is 0. So this is the first case where we see that A is greater than B when A4 is 1 and B4 is 0. So if I look at these two numbers and I see that A4 is 1 and B4 is 0, then I don't have to take a look at the rest of the bits. Now let's see another instance when A is greater than B. So previously we saw that we looked at the MSB. We looked at A4 and B4 and we concluded that if A4 is 1 and B4 is 0, then A is greater than B. Now when should we really check A3? We should only compare A3 and B3 if we see that A4 and B4 are equal. Only then we should check the bits A3 and B3 and see whether A is greater than B. So in this example, the value of A is 12 and the value of B is 8. So this is their binary representation. Over here we can see that the bits A4 and B4 does not give us the information whether A is greater than B, because these two bits are equal. So only when A4 and B4 are equal, we will look at A3, B3. Now we see that A3 is 1 and B3 is 0. So we can conclude that again A is greater than B, because these two bits are equal and A3 is 1 and B3 is 0. So this value is, the value of A is greater than the value of B. So this is the second instance where you can see that if A4 and B4 are equal and if A3 is 1 and B3 is 0, then also we can say that A is greater than B. Now let's look at another case where A is greater than B. So the value of A is 10 and the value of B is 8, and this is their binary representation. Now let's look at their values. So A4 and B4 are equal. A3 and B3 are also equal. So looking at A4, A3 and B4, B3, we don't know for sure if A is greater than B. So only then we will look at A2 and B2. And since A4 and B4 were equal and A3 and B3 were equal, looking at A2 and B2, we find that A2 is 1 and B2 is 0. So this tells us that A is greater than B. So apart from these cases, we also know that if A4 and B4 are equal and A3 and B3 are equal and A2 is 1 and B2 is 0, then also we can say that A is greater than B. Now let's look at the last case where A can be greater than B. So the value of A is 11 and the value of B is 10, and this is their binary representation. So let's see. Over here, A4 and B4 are equal. So we still don't know whether A is greater than B. We see that A3 and B3 are also equal, and likewise A2 and B2 are also equal. Only then we will take a look at A1 and B1. We see that A1 is 1 and B1 is 0. So finally we can say that yes, A is greater than B. So in this case we see that if A4 and B4 are equal and A3 and B3 are equal and A2 and B2 are equal, only then we will look at A1 and B1, and if we see that A1 is 1 and B1 is 0, then we can say that A is greater than B. till now we have only come up with the conditions. Now we will translate these to Boolean equations. So again, just to review, A is greater than B if one of these four conditions are met. And to translate these to Boolean equation, we will need the help of these functions. Now, if you recall, these functions were shown when we were learning about equality checking. So the function x1 will check whether the bits a1 and b1 are equal. So we will pass a1 and b1 through a NOR gate. So this says x1 equals to a1 NOR b1. And over here, the function x2 will check whether a2 and b2 are equal. So a2 NOR b2, and so on and so forth for x3 and x4. Okay, why do we need this? You guys will get to know shortly. So let's first translate this. So a4 is 1 and b4 is 0. So now we will write the equation for a greater than b. So a can be greater than b if a4 is 1 and b4 is 0. So if you translate this to Boolean equation, to a Boolean term, it will be a4 1 and b4 0. So b4 bar. So this is the first term of our equation. Now for the second instance, if a4 and b4 are equal, then we check if a3 is 1 and b3 is 0, then also we can say that a is greater than b. So to check a4 and b4 are equal or not, we will use the function x4. So if a4 and b4 are equal, which is x4, and a3 is 1 and b3 is 0, then we know that a is greater than b. So this is going to be the second term of our equation. So this is the second term. Now let's look at the third case. A is greater than b if a4 and b4 are equal, a3 and b3 are equal, and a2 is 1 and b2 is 0. So to check a4 and b4 are equal or not, we will use the function x4. For a3, b3, we will use x3, and a2 is 1 and b2 is 0. So a2 will be as it is and b2 will have a bar because b2 is 0. So this is the third term of our equation. Now let's look at the final case when a is greater than b. For this case, if a4 and b4 are equal, that is x4, and a3 and b3 are equal, so and x3, and a2 and b2 are equal, so x2, and a1 is 1 and b1 is 0, then a is greater than b. So translating this line to a Boolean term will look like this. So this is the final term of our equation. So this is the equation to check whether a is greater than b. If any of these conditions is true, if any of this term is true, then we know that a will be greater than b. And notice that these terms have been separated by or because this is how we wrote our condition, that a is greater than b if this is true, or if this is true, or if this condition is true, or this condition is true. Hence these terms have been separated by or, which is plus. Since we have already finished writing the conditions and an equation to check whether a is greater than b, now if you understood it properly, then you should be able to write the conditions and the equation for checking whether a is less than b, which means whether b is greater than a. So pause this video at this point and try to write the conditions by yourself and also translate those conditions to an equation. So to check whether b is greater than a, the process will be very similar to how we found out whether a is greater than b. So again, a will be less than b if A4 is 0 and B4 is 1. So at first, if we see that A4 is 0 and B4 is 1, then we know that A is less than B. So this is our first condition. And translating this to a Boolean term, A4 is 0, so A4 bar, and B4 is 1, so B4 as it is. So this will be the first term of our equation. Now, the second case where A is less than B, if A4 and B4 are equal, then we will look into A3 and B3. And here, if we see that A3 is 0 and B3 is 1, then we know that A is less than B. So, or if we see that A4 and B4 are equal and A3 is 0 and B3 is 1, then we know that A is less than B. So translating this, A4 and B4 equal means X4. So X4 and A3 is 0, so A3 bar, and B3 is 1, so B3. So it's separated by a or, because this is one condition or this is the other condition, and this will be the second term of our equation. Now let's look at the third case where A is less than B. So if A4 and B4 are equal and A3 and B3 are equal and A2 is 0 and B2 is 1, then we know that A is less than B. So translating this, A4 and B4 equal means X4 and X3, because A3 and B3 are equal, and A2 is 0 and B2 is 1. So A2 will be written with a bar, A2 bar, and B2 as it is, as B2 is 1. So this is the third term of our equation. And finally, the last case where A can be less than B, if A4 and B4 are equal and A3 and B3 are equal and A2 and B2 are equal, then we look at A1 and B1, and if we see that A1 is 0 and B1 is 1, then A is less than B. So translating this, A4 B4 equal means X4 and A3 B3 equal means X3, and X2 represents that A2 and B2 are equal, and if we see that A1 is 0, so A1 bar and B1. So this will be the last term of our equation. So this is the final equation to check whether A is less than B.